In this video, I will be explaining my code for assignment 3. The first part of the assignment is sort and search. I have used the insertion sort.py provided by the professor to sort by both suit and by value. For the first method, to-do method, which was the str string method, I have used the isSorted method that I have also created to update the status of the deck. If isSorted is true, then it is sorted, else then we update the sorted status to shuffled. The next function, which is the isSorted function, this method is a property method that determines whether the cards in the deck are sorted by suit and value. It iterates through the cards in the deck and compares each card with its adjacent card. So if it finds any instance where the suit of the current card is greater than the suit of the next card, or if the suits are the same but the value of the current card is greater than the value of the next card, it returns false, indicating that the deck is not sorted. The loop iterates until the second to the last card to avoid accessing an index out of range when comparing the last card with the next card. If the loop completes without finding any unsorted cards, it means that the deck is sorted both by suit and value, and the method returns true. The third to-do method is sort method. The sort method uses the insertion sort algorithm to sort the cards in the deck by suit and value. It iterates over the cards starting from the second card, index 1, and compares each card with the cards before it. The goal was to find the correct position for the current card within the already sorted portion of the deck. Inside the loop, there is a while loop that shifts the card to the right until the correct position is found, and it compares the suit name of the current card with the suit names of the cards before it. If the suit name of the current card is greater, it means that the current card should be placed after the compared card. The loop continues until it finds the correct position or reaches the beginning of the sorted portion. After finding the correct position for the current card, it is inserted at that position by assigning it to self.cards j+1 position. And lastly, the code includes two loops for printing the sorted cards. The first loop prints the value names of the cards, for example, ace, 2, 3, and etc. And the second loop prints the suit names of the cards. The fourth function that I have done is the search function. This function prints the index of the card in the deck if found. The card description returned from the describe card function is stored in the variable card. It uses the index method to find the index of the card in the self.card list, which represents the deck. Finally, it prints the index of the card in the deck using the print function, along with the message indicating the index. Lastly, in the assignment, there was a question that was asked. The question was, what can you do to make the search a constant time lookup? To make the search a constant time lookup, we can leverage a dictionary to store the card description as keys and their corresponding indices as values. By using a dictionary, we can directly access the index of a given card description in constant time. And there are several ways we can modify the code. For example, we can update the deck class constructor, the init function, to include a dictionary self.card indices to store the card descriptions and their indices. So as you can see, here in the main, we've created the deck object, and then I use the deck object to call the to-do functions that I've created. So here I call the search, deck.search, deck.string after the search, just to show you just to see the status of the deck, if it's shuffled or sorted. And here is the search function that gets the indices index. And lastly, here's the sort, I call the sort function, and then the status function again. So as you can see, when I run, I choose, let's say I choose 2 clubs, and then enter a random number. And then it goes to shows you the index of this card that I chose was 1. I just print out the sorted cards by value name and then by suit name. The second part of this assignment is trees. In this part of the assignment, I have also used professor's code binary tree bintree.py for the binary tree. So here's the code that I have imported from the professor's code, and then here is my code. So I will explain my code here. First, I use the pandas library to get all the numbers from the randomnumbers.csv file. Then the insert method is called on the tree object for each number in the numbers list. This populates the binary tree with the numbers from the CSV file. Then I have also created the count leaves function. This function is defined to recursively count the number of leaf nodes in the binary tree. And it takes a node parameter representing the current node that is being examined. In the function, if the node is none, it means we have reached the end of the branch and return 0. If both the left and right child of the node are none, it means that the node is a leaf node and we will return 1. Otherwise, we recursively count the leaves on the left and right children of the node and then return the sum of the leaf counts. The count leaves function is called with the root node of the tree, and then the result is sorted in the variable num leaves. Then I have also created the height function. This function is defined to recursively calculate the height of the binary tree. It takes a node parameter representing the current node that is being examined. In the function, if the node is none, it means we have reached the end of the branch again, and we return 1 to account for the empty subtree. Otherwise, we recursively call the height function on the left and right children of the node and store the results in left height and right height. And we return the maximum left height and right height representing the height of the subtree with the maximum height, and then add 1 to account for the current node. Then the height function is called with the root node of the tree, and the result is stored in the variable tree height. So as you can see, and then I use the print function to print the number of the leaf nodes and the height of the tree. I got the values that was expected. The number of the leaf node is 31 and the height of the tree is 14.